Hi, in this video, we are going to continue on Unit 6, Periodic Table, and right now, we will move on to Group II metals. Now, first of all, the common name for Group II metals are called alkaline earth metals because they are able to react with water to form an alkaline solution. Now, let's talk about the physical property. Now, we say that for alkaline earth metals, they all have a relatively low density as contrast to what we generally think that metals are having high density. However, when it comes to putting into water, all group 2 metals are able to sink in water. That also tells you that all the group 2 metals are actually denser than group 1 metal. Okay? Now the second part here is quite similar to group 1 metal. We say that all these metals, if they are freshly prepared, freshly extracted, they are silvery in appearances. However, when they are exposed to the atmosphere, then they will tarnish gradually, forming a grayish appearances. And the reason is quite similar as group 1 metal because the metal reacts with oxygen in air to form grayish metal oxide. Okay? So what you're seeing, the grayish appearances, is due to the oxide form on the surface. Okay? Now, down here, that would be some chemical properties. Now, for group 2 metals, they are able to react with oxygen, they are able to react with halogen, such as chlorine. So all this reaction could take place similarly to group 1, but of course, it is less reactive. Now here we would like to particularly look at this reaction, which is the reaction between water. Okay? Now again, please highlight this part because again, this is a very important reaction. So here, group 2 metal reacts with water. We use calcium as an example. Okay? Now when calcium reacts with water, they give us calcium hydroxide and hydrogen. We have two different products. And I also want you to pay attention to the fact that calcium hydroxide is actually alkaline. Okay, it's actually alkaline. However, it is slightly soluble. Slightly soluble in water. Okay? And on the other hand, for hydrogen, of course, it is highly flammable. Okay? And in fact, calcium hydroxide, if you remember in Unit 4, when we talk about the calcium cycle, we did talk about calcium hydroxide. As a solid, it is called slaked lime. As a solution, a saturated solution of calcium hydroxide is referred to as lime water. And at that time, we know that calcium hydroxide is actually not very soluble in water. It can dissolve a little bit, and as it dissolved, they form an alkaline solution. Okay? Now, knowing the product will also tell you some expected observations. Now, first of all, part A, we will see colorless bubbles are being produced. And the bubbles are, of course, hydrogen gas. Okay? Now, you may ask, so for this reaction, it produces hydrogen gas and we will see the colorless bubbles. Then what about group 1? Now, when we go back to the previous table where we say group 1 metal reacts with water, they also produce sodium hydroxide and hydrogen gas. They also produce hydrogen gas. But why don't we see any bubbles here? Now, actually, the reason is because you need to know the meaning of a bubble. Now, bubble is basically when you have a gas that is insoluble in water and this gas is formed under the water. Then the gas will exist as a bubble rising up to the surface and get dissipated. Alright? So the key is you want this gas to be formed under the water. For group 2 metals, since they sink in water, therefore the gas produced is produced under the water. However, for group 1 metals, if you remember, they are able to float on water surface. So the gas, the hydrogen gas produced is not underneath the water. That's why we don't see any bubbles. Okay? Now, Later on, we will also give you the demonstration showing you how we can collect the hydrogen gas using a very classic setup. Now B here, we say colorless solution turns milky. Right? Why does it turn milky? This is because, like I said, calcium hydroxide is only slightly soluble in water. So at the beginning, you may not see any milkiness, but as the reaction proceeds, as more and more calcium hydroxide is produced, and then the solution is starting to get saturated with calcium hydroxide, then any additional calcium hydroxide will not be able to dissolve and therefore exist as white precipitate, making the solution milky and cloudy. All right? So this is the idea. And part C here, again, if you add the universal indicator, then the water changes from green to purple. And the reason is because the calcium hydroxide produced dissolves in water to form an alkaline solution. Okay? Now, after looking at the observations, exemplified it using calcium, let's look at the other members of Group 2. Now, like I said, it would be best if you can memorize the first 3 members of Group 1, Group 2, Group 7, Group 0. Okay? So for Group 2, the first member is actually beryllium, okay? Followed by magnesium, followed by calcium, okay? Even though we say Group 2 metals, they are able to react with water, not all the Group 2 metals are able to react with water. So here, we say that, first of all, the reactivity of Group 2 metal increases down the group, meaning that beryllium is the least reactive, calcium is the most reactive. So calcium is able to react with water, but beryllium and magnesium has no reaction with water. Magnesium can at most react with steam, but not water. Okay? On the other hand, strontium. Strontium is the metal, is the Group 2 metal under calcium on period 5. And according to the trend, strontium is more reactive than calcium. So of course, strontium is able to react with water and even reacts more vigorously. Okay? So these concepts are quite similar to the Group 1 metal. Okay? Now, on the right-hand side here, this is a very classic experiment showing you the reaction between calcium and water and how we can collect the gas produced and therefore test the gas produced. Okay? So before I go into this page, we will first look at a demonstration. Now, I'm going to demonstrate to you the experiment of investigating the reaction between calcium and water. Now, first of all, we have a large beaker here and an inverted funnel. Here we have 3 pieces of blue tack, which in our notes, they are called the plasticines. Later on, I will explain to you the purpose of the plasticine. And over here, we have a test tube filled with water. So first of all, we are going to transfer some calcium granule into the large beaker. Place the calcium granule in the center of the beaker. After that, place the plasticine into the beaker. Then put the inverted funnel on top of the calcium granule. Now, prepare yourself a large beaker of water. And what I'm going to do right now is I'm going to quickly pour the water into the apparatus and at the same time put this test tube on top of the stem of the inverted funnel. Now the reaction takes place quickly, and you will be able to see a lot of gas bubble produced at the beginning. And now you also see the solution turns milky at the bottom here. Now the formation of gas bubble is due to the formation of hydrogen gas, and the milkiness of the solution is actually due to the formation of calcium hydroxide, which is slightly soluble in water. Therefore, once the solution is saturated with calcium hydroxide, the excessive calcium hydroxide will be able to form white precipitate, therefore leading to the formation of the milkiness of the solution. Just now, did you notice that there are some pumping action occurring, right? So the pumping action is due to the pressure building inside the funnel. Now, in order to minimize the pumping action, we use the plasticine to lift up the inverted funnel so that it is allowed the pressure inside the funnel to be equalized with the outside pressure. Also, lifting up the funnel allows the water to reach in to the interior of the funnel, allowing the calcium granule to react. Now, we are going to test the gas collected from the test tube using a burning spin test. A pop sound indicates the presence of hydrogen gas that is collected by the test tube, which further confirms that the reaction between calcium and water produces hydrogen gas. Now, a few drops of universal indicator is added to the reaction mixture. The solution changes from colorless to blue, showing that the solution is alkaline. And that's the end of the demonstration. Alright, after watching the demonstration, let's go back to our note, page 41, where we will highlight some key words, key points related to this setting. Now, in this setup, first of all, we see the large beaker, we see the inverted filter funnel that is supported by few pieces of plasticine. And here we have some calcium granules. They are able to sink at the bottom, and at the same time as the reaction between the water and calcium proceeds, colorless bubble is produced, and these bubbles are the hydrogen gas, which can be collected by this test tube. At the end, the hydrogen gas will all be collected inside the test tube here. Now, first of all, the calcium is something than water, therefore it sinks at the bottom. So this one has to do with the density, and this one, calcium is denser than water. Okay? The second sentence here, calcium reacts with water to form two different products. It is going to be calcium hydroxide and hydrogen gas. So make sure you know how to write down the word equation. So we start with calcium reacts with water to form calcium hydroxide and hydrogen gas. Okay? Now, we see colorless bubbles. And this colorless bubbles is obviously due to the production of hydrogen gas. Now, these gases is collected using the method of, and here the method of collecting the gases with the first fully filtered test tube, and then we turn it upside down into the water, and then the gas kind of displacing the water inside the test tube, and this one is called water displacement. In fact, we kind of learned about this in Form 1 science. And the identity of the gas can be tested by, of course, the burning spin test. And of course, the test gives out a pop sound. Okay? Now down here, we say that since calcium hydroxide is only slightly soluble in water, so once the water gets saturated, it starts to form white precipitate. And this one is responsible for the milkiness of the mixture. The white precipitate is responsible for the milkiness of the reaction mixture. And of course, if we have added the universal indicator, the indicator should changes from green to blue, or the solution should changes from colorless to blue. Okay, so this one, if you wish, you can mark it down. And lastly, talking about the uses, the purpose of the plasticins. So here, the plasticin lift up the inverted filter funnel. It prevents something from building up inside the funnel. So here, it prevents the pressure from building up inside the funnel, which may cause splashing of the solution. Okay? So like these are all the key concepts related to this experiment. Okay? Now before we move on, I just want to ask one question, or we try to compare. We try to compare the reaction between Group 1 metal and water versus the reaction between Group 2 metals and water. We want to look at some similarities and differences. So maybe we jot down something. Maybe we make use of this empty space on the previous page, page 40 here. So we try to look at the reaction with water. So Group 1 versus Group 2. Okay? Now, first of all, we try to look for similarities. So what are they in common? So similarities, that includes, of course, they produce an alkaline solution. Okay? And they both produce hydrogen gas. Okay? So these are the similarity. But what are the differences? We have Group 2. Okay? We try to make use of a table. So first of all, we look at the density. Okay, and therefore the sink float. So we say that Group 1, they are less dense than water. Therefore, they float. Here, Group 2, they are denser than water. Therefore, they sink. Right? So secondly, we will say the rate of reaction, or how the extent of reaction. If you look at the extent of reaction, then we say that Group 1 is faster or more vigorous, and Group 2 is slower, less vigorous. Okay? And we can also compare whether they catch on fire or not. Okay? So does it burn? Okay, Group 2 may burn. And some will always burn, like potassium, they will always burn, but sodium, sometimes they burn. Lithium, they never burns. So I will put down here, may burn, but here, never burn, right? You don't expect to see a metal burn underwater. Otherwise, that would be too exciting to watch, okay? And also, you can think about, is there any precipitate? Is there any precipitate that is formed? Now, for Group 1, there's no precipitate And for group 2, for calcium, and when they form calcium hydroxide, that will be the precipitate form. So the calcium hydroxide precipitate, okay, may form. Now, interesting though, for other members of group 2 metals under calcium, which includes like strontium, barium, these two, their hydroxide is more soluble than calcium hydroxide. Therefore, they won't form any precipitate. So calcium hydroxide, because it is slightly soluble in water, it can form precipitate. All right. So here we try to compare the reaction with water, group 1 versus group 2, which will probably be a very popular question in the exam, because we have so many things to compare. All right. Now let's move on to group 7 nonmetals, the halogens. Now this time, group 7, if you go back to the periodic table, you see group 7 is on the right-hand side of the periodic table. And if you remember, one of the periodicity, one of the recurring pattern on the periodic table is that the element is changing from metal to non-metal. So basically the elements on the right-hand side are the non-metals. So group 7 is all the way to the right-hand side, and therefore all the group 7 elements are actually non-metal. Okay? So therefore, here we are talking about group 7 nonmetals. Now, halogens are their other name, so make sure halogens are referring to the group 7 nonmetals. Okay? Now, first of all, the physical properties of these halogens. First of all, they are having low melting point and low boiling point, so which is in basically general properties of nonmetals. Most of the nonmetals, they are having low melting point and low boiling point. But we have an exceptional case such as carbon, which has exceptionally high melting point. Now the second part here, volatile. But remember, volatile is only applicable for a liquid such as bromine or iodine. Now bromine, iodine, iodine they will sublime rather than, because iodine is a solid, so basically they are easy to vaporize. Now thirdly, they are colored. Now this one is the most important part about the color. Because for halogens, they have different appearances. They have different physical state. They also have different colors. So make sure you spend some time memorizing the physical properties, especially the appearances over here. Now, here you can look at the following picture. So fluorine is a pale yellow gas. So it's a gas pale yellow in color, but we don't often have a chance to see it. Now chlorine is a greenish yellow gas. Again, it's a gas and it has a greenish yellow color. Make sure you say greenish yellow or yellowish green. In the exam, we don't accept green or yellow. Okay? Bromine is a liquid. Is actually one of the two only liquids on the periodic table. The other liquid is mercury. Now, bromine is a dark brown liquid. Iodine is a black solid. So you see, gas, gas, liquid, solid, and they have different colors. Make sure you memorize the color. And remember, these colors are the elements. Okay, some of them are able to mix with water to form a solution. And when they mix with water to form a solution, they may have different colors. For example, iodine, when it dissolves in water, it has a brown appearances. It has a brown color. So it is no longer black, right? Chlorine, when it dissolves in water to form a solution, the solution is colorless. So these are the color of the element only, okay? Now, on the right-hand side here, this is a very, very important trend that you need to memorize. Remember, for group 1 metal, group 2 metals, their reactivity increases down the group, meaning that the more bottom the position of the element is, the more reactive it is. However, for halogens, the reactivity actually decreases down the group. meaning that among the first 4 members of the halogens, actually fluorine is the most reactive and iodine is the least reactive. Okay? So this one is a little bit different. Now, this table showing you some chemical properties which are not very important. So first of all, they are toxic. So halogens are all toxic. Okay? They are toxic in their elemental form. So if you have like fluorine, chlorine, bromine, iodine, so these guys are all toxic. Now you know chlorine is toxic. That's why it can be used to kill the germs in the swimming pool. Iodine is also toxic. Therefore, we have something called iodine tincture, which is when we have injuries on our knees or whatever body part, we will apply the iodine tincture to perform disinfection. Okay. However, they are harmless in halide form. Now, halides basically means halogen compound. Now, do you remember, for example, table salt? We call it sodium chloride, NaCl sodium chloride, right? Let me put it down here. If you have NaCl, this is sodium, and this is chloride, isn't it? Okay. Now, we won't say sodium chlorine, right? Because when chlorine exists as a compound, the name changes into chloride. Okay? So actually, this IDE at the end is coming from halide. So all these halogens, when they form a compound, they will have to change the name into IDE at the end, having the IDE suffix. For example, if you have like sodium, okay, NaBr, then this one is called sodium bromide. Okay, sodium bromide, sodium fluoride, sodium iodide, something like that. Okay, so anyway, halides are halogen compounds, and interestingly, they are harmless. So as a compound, they are completely harmless. So you see, sodium chloride is the table salt. Every day we are eating the sodium chloride, but it is entirely harmless. Okay? So here, part 2, reaction with alkali metals. We actually did talk about that when we talk about group 1 metal. So we say sodium able to react with chlorine to form sodium chloride. Actually, not only chlorine, it can also react with bromine, it can also react with fluorine, it can also react with iodine. Okay? So you see the suffix of the halogen changes when you form a compound containing the halogen. So you say IDE, IDE. Okay? Now, lastly, reaction with hydrogen. Reaction with hydrogen. So hydrogen and halogen can react to form hydrogen chloride, HCl. Okay? And this reaction is very vigorous as well. Okay, so that's it for today's video.